why understanding levels of measurements is important in statistics. A year ago during our grade school, we learned that 2 plus 2 equals to 4. Quantifies as one of the life's everyday certainties along with taxes and death. What I mean by not all the numbers have the same interpretation. For instance, it wouldn't make sense to find the sum of two patients' ID, right? Or to clarify that. Or when we viewed as an indicator of our academic achievements like GPA of 2.0 equals a GPA of 4.0. A student has in semester 1 2.0 GPA, in semester 2 2.0 GPA. Still the sum would be 2.0, not 4.0, because GPA is an average. So this shows that we have a different type of data and the concept of levels of measurement was developed. Therefore, it has implications for the appropriateness of various statistical procedures or arithmetic operations. So basically, the levels of measurements tell us how well the numbers, the letters, the labels represents the real characteristics of the variable, the real attributes of the variable. It helps us to decide that which arithmetic operations are appropriate or which statistical procedures we can use, because we have a different type of data like nominal, ordinal, interval, ratio. So finding the average from the nominal data, it won't make sense, right? However, you can apply frequency. You can count them. Let's say in the study you want to know that how many females or how many males are participated. So you are counting them. So this will give you the idea, the levels of measurements will give you the idea that on which this type of data I can apply this maths. Same way you would be able to decide that, let's say for example, in the ordinal data you can order them but not subtract it meaningfully. But with the interval and ratio data, you can do sum, you can find frequency, you can subtract it. So more complex levels of measurements are associated with continuous data, that is numbers. And it permits a wider variety of mathematical operations or statistical procedures. Say for example, with nominal data you can apply, if you are having two groups, you can apply chi-square. With ordinal data you can apply, say for example, Mann-Whitney test or Kruskal-Wallis test if you are having more than two groups. Same way with the continuous data, with the ratio data, you can apply t-test or ANOVA based on the number of groups you have. If you have two groups, apply t-test. If you have more than two groups, based on the statistical assumptions, you can choose, you can decide that which test would be appropriate. So knowing the levels of measurement is really important. I hope this convey what I intended to express.